Hello all. In this video, I'm going to talk about the accumulator pattern. This is a pattern that is very common across every programming language, having to do with loops. And it's one of the first patterns that you might see in Python when you learn about something like a for loop, because it's where most of our loops are doing this kind of accumulation. So we want you to understand that there's a pattern here and that you can program using that pattern, and it'll make your life easier when you recognize it. All right, so here are my notes about the accumulator pattern. So this is one, as I said before, among many patterns, and so you can go out and find resources that talk about design patterns in computing. There are many, many more than we're going to talk about. But this specific one has to do with loops and a particular kind of common behavior we have with a loop, which is that our loop is iterating and there is some information collected or constructed each time through the loop, and we want to accumulate that data in one place. So we might be building a list, we might be calculating a number, we might be building a string, but somehow each time through the loop we get a little bit more information that we want to add in to what we're accumulating. And at the end of the loop, we have a complete list of data. So we want to, I have a couple of examples here just to kind of give you a sense of what the accumulator pattern is all about. Move this up a little. So suppose that you have a list full of numbers and you want to add them up. There actually is a built-in function for adding them, but you could also do it by writing a loop and iterating through the numbers in the list and adding each number each time through the loop to a variable that will hold the result. Suppose that we know we want to do the numbers from 0 to n, and we want to build a list that holds the squares of each number in order. Maybe we want to build a string that contains the data from each list, separated by a star from the next. So we're going to take all the data in a list, convert it all to strings, and concatenate them all together. Those are all places where we need an accumulator, because we need somewhere to be able to hold the partial sum of the numbers as we go through the iterations of the loop. We need a place to hold this list, and then we're going to add on to the list each time through the loop. And here we are iterating through the data in the list. We want to build this string and have this string stored somewhere so that we can add on to it. It's not always adding on. That is the most common example. So the pattern itself has two parts in the code, but in addition we have an accumulator variable. Sometimes you could even have more than one accumulator variable associated with a single loop. For now, we'll keep to simple examples, but that does happen. So an accumulator variable is an extra variable that you add to the program that holds the value you're accumulating. And the two steps that you see in the code is an initialization step. This is where you create that variable in your code before the loop begins, and you give it some default initial value. And then in the update step, which is inside the loop, we will add to the current value of the accumulator some additional value that is going to help us to compute our full answer. There are a couple of things noted here, like when you initialize the accumulator variable, you want to think about the type of data. So in my examples, in the first case, we had a number as our type of data. In the second case, we had a list. In the third case, we had a string. We would want to make sure that when we initialize our accumulator, it has the right type of data in it. So this first accumulator should be an integer, a number. The second accumulator should be a list. And the third accumulator should be a string. Very often these are default values, empty values. So you might have 0 as the initial value for this adding up the numbers in a list. You would have an empty list or an empty string in the second and third cases. So, and I have that listed down here. 0, empty list, empty string. These are commonly what we use. Inside the loop where we're where we're doing the update, it is absolutely the most critical point is that we have the old value of the accumulator and we're adding to it, and then we save the result back into the accumulator. That's an update step, not reassigning the variable. There are a few examples where you do reassignment, but I don't really want you to think of that as the default behavior. All right, so here I have then a couple of examples. We're going to go and try these out in PyCharm in just a moment. This first one is just a number list. Here you can see this line 2 is where it says sumnums equals 0. That's the initialization of the accumulator variable sumnums. And notice we've got 3 variables involved here. They each kind of have a name. So numList is just our data that we're looping over. Num is our loop variable, so it's being assigned the values from our data list. And sumnums is our accumulator variable. We initialize it to be 0 before the for loop. And then inside the for loop, we have this pattern, which is really common. Sumnums equals sumnums plus something. In this case, plus the number itself. We're looking at the old value of sumnums here on the right. We add a number to it, we get a new number, and we overwrite the old value with this new number that we've calculated. Here you see an example that's using the range function, but it also has an accumulator. So I is our loop variable. I is going to take on the values from 0 to n, inclusive. And so because of that, we set our value in the range function to n plus 1, so we make sure we include n. SQList, that's our accumulator. It's an accumulator variable. We've set it up to be an empty list here, and then inside we're taking the old value of SQList and we're concatenating a new list to it that contains the square of whatever I is. And then we're saving that back into SQList. This is the accumulator pattern, an update step, and before the loop, an initialization step. Before the loop, an initialization step. Inside the loop, an update step. In our last example, I just included a couple different kinds of data. So we have strings and numbers, and we are building an answer string. So that's my accumulator. Data val is the loop variable. It's going to be Henry, and then 20, and then Mora, and then 73. And here again, we're taking the old value of the answer string, we're concatenating new data to it, and then we're saving the result back into the answer string. That's what an update step looks like. Let's take this over to PyCharm. I'm going to copy this example. All right, so I'm going to paste that example into my code file. And right above that, you can see that I wrote out in code with a couple of comments in there as placeholders what this pattern looks like. We have a for loop. We have an initialization step that should come before it. We have an update step inside of it. That's what the accumulator pattern consists of. You can have other steps inside the loop. You could be doing multiple things inside this loop, printing data, doing other calculations, but you will always have an update step somewhere along the way. Oh, I should note also that this word here, pass, this is a special Python command. It's overtly a placeholder. It's a command, it's a statement in Python that just means don't do anything here, just keep going. And we use it when we haven't written the code for something yet. So I haven't actually written the code for this for loop. I just have it in a comment. I need something syntactically to fill in this loop so that Python accepts it as a valid loop. And so the word pass is used for that. It's kind of like if you've ever played a board game where you have the option to pass. It's the same idea here. Now, I do have this example that I copied. We've got a list of numbers here. And then this right here is our initialization. Sumnums is our accumulator variable. We initialize it to 0. We're going to loop through the number list, and then we do the update step. So if I run this, I think everything up above is done. Ooh, I didn't actually print anything, so we don't see a result. Print sum nums. This print is happening after the loop is done. So it prints 35. We could check our math here. So we have 3 plus 1 is 4, plus 20 is 24, plus 15 is 39, minus 4 is 35. So that looks correct. You can also add in here in our for loop a print statement. So we could say print num and sum nums. So I could print out what's happening with that accumulator each step through. So we have 3, the value of sum nums was 0, that was the initial value. We had added 3 to it, that looks correct, and then we have a 1, that turns into a 4, then we have a 20, 24, and so forth. So we can see how it's actually building it and that it is actually doing it correctly. We'll take a look at one of the other examples. I'm going to go and copy that. I'll be right back. I'm going to get rid of this and I'm going to paste in the third example. So here we have a list. It has different kinds of data in it. We're building a string as the result. Just like we did before, I'm going to add a print statement to this. So that we can take a look at that accumulator variable and how it changes as the loop runs. And then we'll have one final print at the very end. So let's take a look at what it does. All right, so it starts off with Henry, and it doesn't print anything. That is because the string itself, answer string, when it's an empty string, that doesn't look like anything when you print it. So it was printed out here, but it just doesn't show up. But Henry is our new data value. We then converted Henry to a string. Well, it already was one. We added a star after it, and we added that to our empty string. And you can see how that ended up. The next time through the loop, answer string was Henry star. And 20 was our new value. We go through the same thing. So the next time through, you can see that we have Henry star 20 star, and then we add more star, and then we add 73 star, and that's our final. So this is doing exactly what we want. Each time through, the answer grows. And as we get more tools, we'll be able to use this accumulator pattern in many more interesting ways than we can right now. But it's still a very valuable pattern, and it just shows up everywhere. So study it and learn to recognize it and how to reproduce it. All right, so this has introduced a programming pattern, something that you want to watch out for and use whenever you can. And I invite you to try some additional examples. You will certainly do so in our activity. Until then, I will see you very soon.